Hello, I'm Rishik from iBoT, and in this session we'll be learning sketching and modeling in Fusion 360. To begin with, let's understand few basic sketching concepts. Sketches form the backbone of any 3D model. To make a new sketch, select the Create Sketch command and then select the plane where you want to draw. This will lead you to a new sketch tab, which contains three essential drop-down menus which will help you sketch. The Create panel contains all the basic drawing tools. The Modify panel will help you edit and refine your sketches. The Constraints panel will help you set relationships between two or more sketch. The Constraints panel will help you set relationship between two or more sketch elements and then log the positions. To begin with, under the Create panel, select the Line tool and draw a simple closed figure. Now to escape from the tool, press Escape on your keyboard. Once you do this, you'll notice two things. The blue shade indicates that it's a closed profile and the blue line tells you that it's an unconstrained sketch. An unconstrained sketch as in, you can move its position and modify it. This might be useful in the early stages, but as you move towards 3D modeling, it is a good practice to have a fully constrained sketch to avoid errors later on. To constrain your sketch, you'll have to specify its constraints and the dimensions. Now, to get a gist of it, let's make this shape of square using constraints and dimensions. Select the horizontal or vertical constraints and select any one of the edges, which will make your sketch either horizontal or vertical depending on which is closer. Now select the perpendicular sketch, which, as you might have guessed it, will make lines perpendicular to each other. Now select the equal constraint and select the adjacent lines. Once this is done, you'll need to specify dimensions using sketch dimension and select any one of the edges. After this, specify the dimension you want. Once this is done, you'll notice that the sketch isn't still fully constrained. This is because it can still move around the canvas. To lock it on the canvas, select the midpoint constraint, select any one of the edges, and select the midpoint of your canvas. This will fully constrain your sketch. After you are done with it, press Finish Sketch at the top. Now that you know the difference between an unconstrained and a constrained sketch, let's quickly go through a few basic sketch tools and constraints. Firstly, select the Line tool. The letters here indicate the keyboard shortcut to access that tool. Select the tool and simply press 2 points on your canvas. You can continue selecting points to make a series of line segments just like a polyline. Now, after you're done with, press Escape on your keyboard to exit from the command, or alternatively, press the green color tick box over here. The rectangle tool lets you create rectangles. You can do this in three ways, but the most common ones are the 2-point rectangle and the center rectangle. To use a 2-point rectangle, select two opposite corners of a rectangle. To use a center rectangle, select the center of a rectangle and simply drag your mouse. Now, you can manually write the dimensions as well using your number keyboard. To toggle between dimensions, press Tab on your keyboard. The circle command lets you create circles. You can do this in many ways, either by specifying center and diameter, specifying the points through which you want your circle to pass, or specifying the tangent lines of a circle. Let's quickly go through each one of those. This is the center diameter circle, the 2-point circle by selecting 2 points, the 3-point circle, select the 3 points from where you want the circle to pass, and the tangent circles, And the tangent circle, simply select the tangent lines and Fusion will create a circle such that the three lines are tangent to it. Another way to do this is by drawing a tangents and selecting the lines. Now as you drag through these lines, you will get a circle of suitable diameter. To remove the excess sketch elements, use trim command. Under the modify panel, you can use fillet to add a curvature to sharp edges. Simply drag the arrow or specify the radius manually. The offset tool lets you select an element and create a copy of it parallelly, as shown. The chamfer tool creates a chamfer at the vertex of two edges. You can specify its dimensions by simply dragging or writing it manually over here. Now, I would suggest you to go through other drawing tools as well, namely the arc, polygon, ellipse, and slot. They do exactly what they say, they create the respective geometry. The spline tool lets you create a free-form curve as shown. Once done, don't press escape here. Tick the checkbox to finish your spline. You can use this green lines to change the curvature and form of your curve. Now let's go through the pattern and the mirror tools. The pattern tool lets you repeat a certain sketch element or a sketch. The circular pattern repeats the sketch element around a center, whereas the rectangular pattern repeats the sketch element along a particular axis. To use the circular pattern, select the sketch elements and specify the center point. You can increase the quantity of repeating units in this box over here. To use the rectangular pattern, select your sketch elements and drag the arrow to create copies. Or else you can manually specify the number of repeating units along each direction and the distance between them over here. You can use the sketch scale feature to increase or decrease the size of your sketch by a certain factor. Select your sketch elements and specify the reference point. Then specify the scale factor over here. I'd like to diminish it by half, so I'm writing 0.5. The mirror tool lets you create a copy of a sketch element with respect to a mirror line. To make a mirror line, I would advise you to use the construction line type. The construction line type is generally used to make a sketch element which you'll be using as a reference to create other elements. It is not actually a part of the entire sketch. Select the construction type, select the line, and make a mirror line. Then unselect the construction type once done. Now, select the mirror line, select the object you want to mirror, and specify the mirror line. Let me hide the constraints for you to have a better look. Notice how when I change any one of the elements of the original sketch, the changes are automatically reflected in the mirrored one as well. The point tool lets you add custom points on your sketch. To use it, simply select where you want to add the point. Notice the triangle here. The triangle indicates that is the midpoint of the line segment. Press escape once done. Another interesting feature is the extend tool here. The extend tool the extend tool extends your line segment to the nearest object or extends it in a specified direction. Another really useful feature is the project tool. The project tool basically projects the outline or the silhouette of a 3D model, which you can then use as a reference for your sketch. Let's see this in action using this helical bevel gear. Select the gear part of the helical bevel gear and select Create Sketch command. Now, select Project and select the outline of the gear by double-clicking it. Once done, press OK. Before pressing OK, ensure you have the projection link on. This basically creates a reference to the original sketch so that when you modify the original sketch, the projected sketch and the elements later on will also show the corresponding changes. Now finish the sketch and create a simple extrusion. Select it and drag the arrow. Now when you edit the original sketch of the gear, you can see the corresponding changes in the extrusion as well. Let's say I want to rotate this sketch. I can do that by using the move and copy tool. Select it, then select the sketch. Now select the move type to rotate and specify the axis. Then simply rotate your sketch by, let's say, minus 20 degrees and press OK. Then press Finish Sketch. Now you can see the corresponding extrusion has also changed. Now let's go through most commonly used constraints. Make a simple line segment and then select the horizontal constraint. Now select your line segment. This basically makes your sketch either horizontal or vertical depending on which is closer. The coincident constraint makes 2 points to coincide each other. Select the line and the point where you want to coincide it. You can also do this to a circle. Simply select the circle and then select the point. Now the circle is restricted to move along this line alone. The perpendicular constraint makes two line segments to be perpendicular to each other. And the equal constraints makes the dimensions of two sketches to be equal. So if I select these two lines, the dimensions of sketches are equal. This also works with circles. So now when I press equal, the radius of the two circles will be same. So when I change uh, the radius of one of the circles, the other changes as well. Notice how when you select a particular sketch, Fusion automatically highlights the constraints which can be applied to it. The concentric circle makes two circles to be concentric. The midpoint constraint identifies the midpoint of your line segment and attaches it with the other one. Now, the two lines always intersect at their midpoint. The tangent constraints makes a line segment tangent to a circle. Notice how when I move the line, the circle moves as well. To avoid this, you can use the fix or unfix constraint. This basically locks the position of a sketch element. Now when I move the line segment, the circle won't move. The parallel constraints fixes the orientation of two or more line segments and makes them parallel. So you can't change the orientation of the lines now, but you can change its position. Next, we'll be looking on few common modeling tools. Under the Create menu of the Solid tab, you'll find several sections. The second section contains tools which will let you create a 3D model based on a 2D profile. The fourth section contains tools which will let you create simple 3D shapes such as box, cylinder, sphere, torus, coil, pipe, and then the fifth section contains the pattern and mirror tool, which works exactly as it did in Sketch. We will go through few tools in the second section, the hole, thread, pattern, and mirror, and few other tools in Modify as well. Firstly, the extrude command. The extrude lets you select a 2D profile and add uh, depth to it in the direction perpendicular to its plane. Another commonly used feature to make a 3D model is Revolve. Revolve lets you select a closed 2D profile, just like Extrude, and, and it rotates it around a particular axis to make a 3D profile. The sweep command selects the 2D profile and it sweeps it across a path to create a 3D model. Here you can specify the taper and twist angle as well. Let's say I want it to taper by 2 I want it to taper by 2 degrees and twist by 30 degrees. Another interesting feature to make a 3D model is using Loft. Loft basically creates a transition between two different sketch elements in different planes. When you use Loft, the order of selecting the planes is important. Once done, press OK. Now the press pull feature in the Modify menu will let you select a face and extend it or cut it based on its trajectory as shown. Coming back to the cuboid and cylinder, the fillet tool from the Modify menu will let you add a fillet, that is, it will let you round off the sharp edges just like in Sketch as shown. The chamfer tool lets you add a chamfer at an edge. The shell tool hollows out a 3D model as shown. The move tool lets you rotate your models, move it, and create a copy as well. The combine tool combines two different 3D models. The hole tool adds a hole to your 3D model as shown. You can change its dimensions and hole type over here. Whereas the thread tool adds threads to your 3D model as shown. The mirror tool lets you mirror out your 3D models with respect to a mirror plane. And the pattern tool, just like Sketch, you select a 3D model, select the axis, and then repeat the 3D model. Finally, the scale tool lets you select a 3D model and change its size based on a scale factor. I would highly recommend you to explore other features as well. Next, we'll be applying what we have learned to make a simple piston and a connecting rod. First, we'll be making the piston cap. Select the new component from the Assemble drop-down menu and name the component as piston. Then press enter. Now, make a new sketch In the ZX plane, make a rectangle of dimensions 90 and 42.5. Once this is done, select the Fit Point Spline tool, select the corner and snap it anywhere on the edge. Then press the checkbox over here. Now use the Sketch Dimension tool and select this point and this line. Ensure the distance is 5 mm. Toggle the green line to make it a smooth curve and press OK. Now select the line tool and make it a closed figure. Now select the 2-point rectangle again and select anywhere on this edge and make a rectangle of dimensions 4.3 and 3. Now select the Sketch Dimension tool and select the top edge and this edge, make it 7.3. Repeat the same process 2 more times. Or alternatively, you can use the Move and Copy tool over here. Select the lines, enable Create Copy from the box and drag it down by 11.6. Once done, press Finish Sketch. Then press Revolve tool and select these following profiles. Now specify the axis and then press OK. Now create a circle at the bottom of diameter 76. Then Finish Sketch, select it and use Extrude by pressing E on your keyboard. Now extrude it by -85 and press Enter. Go to your home view and select the front view. Now make a sketch in the ZX plane again. Let me hide the bodies for you to see the sketch. Make a circle of diameter 33.8. Press Enter. Now use the Sketch Dimension tool to select the center of the circle and center of canvas and specify the distance to be 27. Once this is done, use the center diameter circle again and make another concentric circle of diameter 45.8. Once this is done, press Finish Sketch. Now select the Extrude command and select the inner circle. Specify the direction to be symmetric and then cut it. Now use the Extrude command once again and select the part between the two circles. Select the start to offset and specify an offset distance of 25 mm. Then select the extend type to object and select the inner profile. Press OK. Now select the mirror tool and select this feature that we have created. Select the mirror plane to the ZX plane and press OK. Once done, go back to your home view. Now go to the right plane and create another sketch, which is the ZY plane. Now hide the body. Now select the line tool and make a line of length 12 mm from the y-axis. Now use the sketch dimension tool and select the origin and your line. Specify the dimension to be 25. Let me hide the dimension and constraints for you to see it in a better way. Now select the mirror tool, select the line, and select the mirror line to be z-axis. Press OK. Once this is done, select the 3-point arc and select the line tool and connect the bottom part of the two lines. Then select the 3-point arc and select the two corners at the top of your lines and the third line to be anywhere on the z-axis. Now use the sketch dimension tool to mark the radius to be 40. If your line goes up, then select the midpoint tool to select the bottom line and the origin. Now as you can see, the radius is 40. Now use the fillet tool and select these lines as follows and specify the radius to be 10. Press extrude and select your sketch. Select the extrude to be of symmetric direction and make sure your operation is set to cut and then press OK. Now you have created your piston cap. Making the connecting rod, firstly hide the piston and its sketches and make a new component named connecting rod. Now select the XZ plane and create a sketch. Make a concentric circle on the Z-axis. Make a concentric circle on the Z-axis of diameter 38, 30, 33.8 and 45. Now select the sketch dimension tool and mark the distance between the origin of your canvas and the center of the circles to be 27. Now create another set of concentric circles below. The dimensions of which are now create another circle exactly below the concentric circles along the z-axis, the dimensions of which is 72 millimeters, the dimensions of which is 72 millimeters. Once this is done, select the sketch dimension again and select the two centers. Give a length of 200 millimeters. Now make a horizontal line passing through its center. Once done, let me hide the dimensions so that you can see it clearly. Now select the line tool. Make a line which is parallel to the z-axis as shown. It should be in the same line as the center of the concentric circles. Make a vertical line and press escape. Now select the line tool again and extend the horizontal line by 10 millimeters. Add a height of 35 millimeters. Now place it exactly below the vertical line which happens to be at 23.5 millimeters. Now simply connect the lines and press escape. Add a fillet of radius 10 millimeters at the sharp edges. Then we'll have to mirror this line. Then we'll have to mirror this line. For that, first we'll have to make a mirror line. Enable the construction line type and make a line along the z-axis. Press escape and disable the construction line type. Now select the mirror tool. Select the following lines. To select multiple lines, use Control and then select the lines. Then select the mirror line. Press OK. Now make a 2-point rectangle at the bottom part. Let the dimensions be 45 and 92 and press enter. Now we'll add a slot. So under the create menu, select center to center slot. Select 2 points at a distance 90 millimeters on the z-axis and press enter. Then make a slot of 20 millimeters and press enter again. Now select sketch dimension. Select the center point of the top concentric circles and select the top center of the slot. Let it be 60. Once this is done, add fillet of radius 10 millimeters at the bottom. Now finish the sketch. Once you're done with the sketch, press Extrude and select the following profiles. Make the direction symmetric and extrude it by 17 millimeters. Ensure your sketches are still visible. Press Extrude and select the slot profile alone. Enable the direction to be symmetric and extrude it by 5 millimeters. Then press enter. So with this you have created a piston with its connecting rod. Now I would like you to create this toolbox, for which I'll be sharing the solution in the next video. Thank you.